Given some probabilities, we can create a frequency table and use it to find other probabilities. To do that, we'll rely on the frequentist interpretation. The probability of an event is the frequency with which it occurs in a sufficiently large sample. But how large is large enough? And to answer this question, we'll introduce the secret to life: productive procrastination. We won't worry about how large is large enough for two reasons. First, it's too large to be usable, and second, it won't make a difference for our purposes. Instead, we'll assume that whatever sample we use is large enough, which means we can use a conveniently sized sample. Now, we can use the probabilities or percentages to create a frequency table to find other probabilities and percentages, and for given simple events, we can use them as column labels. A person has type O blood, or that an animal is a bear. But what if we're given conjunctions or disjunctions? In that case, we'd have to have a two-way table. This allows us to keep track of two events that might or might not happen simultaneously. When constructing a two-way table, remember, each cell corresponds to a mutually exclusive event, and all possible combinations of events must be present. For example, suppose we have an analysis of accidents and 27% involve a young driver, and 38% involve alcohol consumption, and 18% involve a young driver and also alcohol consumptions. Now, since the numbers are given as percentages, fractions with denominator 100, we could use 100, or 10,000, or 1 million. So let's use 100 and see what happens. Suppose there are 100 accidents. It appears that the events of interest are whether the accident involved a young driver, we'll call that Y, or alcohol, we'll call that A. To include all possibilities, we'll include the complementary events, Y complement and A complement. And our table will have an event and its complement as the row headings, and the other event and its complement as the column headings. Note that since we're including the complement, there is no other category, but we should also include the totals. So 27% involved a young driver. Since we don't know anything else about these accidents, this must be the total number of accidents that involved a young driver. 38%, or 38, involved alcohol consumption. Again, we don't know anything else about these accidents, so this must be the total number of accidents that involved alcohol. Because we assumed there were 100 total accidents, then 62 did not involve alcohol, and 73 did not involve a young driver. We also know that 18% involved a young driver and alcohol consumption. This is a conjunction, so it corresponds to the entry in the Y column, A row. We can then find the remaining entries. The A row has a total of 38, and we've accounted for 18, so the remaining cell must be 20. The A complement row has 62, so we should put half in the first cell and half in the second. Or should we? $20 on the table. Are you willing to guarantee it? Because if you're not willing to risk $20, are you willing to risk your job? We only know the total number in the A complement row, but we could split this in many different ways: 31 and 31, 2 and 60, 0 and 62, and so on. While we might make an assumption about how it splits, we should try to avoid unwarranted assumptions. We do know the total in the Y column is 27, and we've already found 18 of them, so the remaining cell has to have 9. And now we can use the 62 total in the A complement row and determine there are 53 in the remaining cell. And from the table, we can see the probability that an accident involved neither a young driver nor alcohol is 53 100ths.